Hello, I'm Mr. Gale.
And I'm Addison.
Today we're going to do topographic maps. So topographic maps, well, what's a topographic map?
A topographic map is a map of the land.
Great. So we have like a map here, or it's not a map, a model of a volcano that Addison made. So if we have this volcano, if we want to make a map of this, can we just put this in a book? It wouldn't work. So if I have like a map of this hill, or a model of this hill, can I put it in a book?
No.
What would happen?
Well,
So
you
can I
can't.
get a book? Give me a book.
Okay.
So we have a book, and it's full of maps. And we try to put this in there, is it going to work?
Mash it.
Go for it.
Yay!
All right. So would that really work?
No.
Yeah, that
You
doesn't
can
work.
put more-
All right, so what we're going to do is actually make a topographic map, a model,
It's upside down.
a model that goes on paper, because it just doesn't work. No matter how much you want to smash that model on paper, it's not going to work. So I'm going to use something we find in our kitchens, a potato.
A potato.
A potato makes a great land model. So we have here, say it's an island in the ocean.
And it's also, and this potato is also cut.
So we're going to basically make this potato into a model that fits into a page. Again, we can't,
Mash it.
it's not going to work. So let's find a way to do this. Okay. So we're going to take this potato and we're going to put it on paper. We do this by slicing it, taking layers. We're going to count the elevation or change in height as it goes up by using a,
Roller.
can you hold my ruler? Now actually, let's move this out of the way so we don't mess up the great volcano. And I'm going to measure using centimeters. Now, in real life, you're going to use meters. You usually count like 20 meters, 50 meters. We're going to use one because it's a potato. So I'm going to make a little tick mark every centimeter going up this potato. 1 centimeter, 2, 3, 4, 5. I can't go to 6 because that'll be above it. So go to the side here. Ruler, please. All right. Do the same thing.
And there I have for the uno.
1.
Dos, tres, cuatro, cinco.
And we can't go any higher than that. All right, let's go one more round. We go all the way around this potato to find the elevation change.
Uno, tres,
Hmm.
cuatro, cinco, seis.
We can't get to 6. It's almost a 6, but not quite. Okay. So now we have marks around it, our change in elevations. We're actually going to go around all the way and make the lines. Right, so now I have the slice of potato. I'm going to draw each layer on the paper. Basically, it's going to be a topographic map. So I got the first layer drawn here. Basically, just laid it right here, and I traced around it. Now I'm going to use a second layer, or second point of elevation, and trace around it also, like so. Cool. Let's go to the next layer. Line it back up. Go to the next layer. You notice the lines are really close because that part of the potato is really steep. It's not going to be perfect, but it works. Another layer. Does it get a little bit messy here? Uh-oh. Did I stop? See how that worked? Nope, see, my potato pin stopped working. Another layer here. You may have noticed that the layers actually get more spaced out now. That's because the slope is more gradual, there's less change. And the last layer, make sure you get about right. Right there. And this last layer of the potato are our imaginary island. As we see, if we look at this side view or lateral view of the potato, we go this way. It goes up, and it's a gradual slope going down. That's represented by this map here. So we start off at the very bottom, in this case to be sea level, which is going to be 0 meters. Now we said for our map, every centimeter going up will be worth 20 meters. So our index is 20 meters. Each time we go up a line, we're going by 20. So 0, 20, so 0, 20, 40, 60, this will be 80, this will be 100, so going by 20s, 0, 20, 40, 60, 80, 100. The last one will be 120. Now the top of the hill is not flat. You see here, it's a little curve to it. It's almost a full centimeter thick. So I'm going to use guesstimation here. You'll be actually given this value. The very top of the potato, the very peak, can be represented by a triangle, a little dot. And they'll give you a value. We'll say right now this value is 133. You don't make that value up, you always be given that. So the total change in elevation goes from 0 to 133, counting by 20s. And we see this potato just like that, fits on that map. Remember, because we can't smoosh in the paper, so we use topographic maps. Now you also can see the same map sideways. So if you see it sideways, it'll be drawn just like this. I know it's not a great picture of it. And you see drawn like this, and you see it sliced like so. Of course, that's not perfect. So you have a top view, topographic, or a lateral view. You see it both ways.